next part of the series. In this part, we're gonna create UI for our game. But beforehand, let's take a look at our hierarchy and clean it up a little bit, since it's a bit messy and we will need a structure to count the coins that we have in the game. Let's start by creating a general object. This will hold objects. And let's create sub-objects for that. That will be coins, hearts, checkpoints, and let's put them all where they belong. And let's just bring in our end level in here as well. With this, we'll be able to keep track of everything in the level a bit more clear. Next, let's start creating our UI. To have UI elements, you will first have to create a canvas. Go into your creation and go to UI and create a canvas. Canvas is where all the images will be displayed. We can leave it called canvas, and canvas will also come with an event system. Event system basically listens to the player clicking. If we double click on our canvas, you will see that the canvas is actually very large. It's used for us to have large space to work on while it's going to overlay on top of our game. Let's look at some of the components in our canvas. One of the most important ones is the render mode. There are 3 different render modes. Render mode overlay means that it will be always attached to the front of the camera in front of everything in the game. Screen space camera means that the UI will be looking at the camera. However, if there's a 3D element in front of some of the UI elements, it will actually overlap instead of being behind it. And lastly, world space camera will actually let you place the UI elements anywhere. So if an NPC has like a thought bubble or something, it will hover over them instead of right in front of the camera. We're going to keep our UI as an overlay, as it will cover up anything that we want. Next, canvas scaler is very important. It determines how the UI scales with different screen sizes. Constant pixel size determines that the screen will always be the same based on given pixel dimensions. Constant physical size will do the same thing, but on physical dimensions of the screen. What we want to do is scale with screen size. This means that this will change with different screen sizes, and the reference resolution is the resolution we want to work. We're going to change it to the standard 1920 by 1080, and everything will always scale in accordance to that. Next, let's create a UI element. We're going to start off by creating a health counter for our player. Let's go into our canvas. We're going to go to UI, and we're going to create an image. We're going to call this heart. And we can zoom in on it. Right now it's just a square with no sprite attached to it, and that's what we're gonna have to do. So let's go to our sprites, let's go to our sprite sheet, let's find the heart, and let's attach it. There we go. Let's zoom out on our canvas, and let's bring our heart to the corner over here. The placement of this heart will always react to the center of its anchors. So let's take a look at it in game and see how this looks. As you can see, the heart is right there. And if I change the aspect ratio, the heart moves more towards the center as the resolution changes. We don't want to do that. We want the heart to always hover in the top corner. So we're going to change our anchors to be right here. If we do that, the heart will always stay where we placed it, because it always will use the reference of that corner as its distance. Let's also change our aspect ratio to be 16 by 9. Let's change the scale of our heart. Let's make it all 2. Something unique to the UI images is that it has a different type of image rendering. We've seen simple, slice, and tiled before, but this time we're going to use filled. Filled actually allows you to control how much of the heart is visible at a time. So we will use that to determine how much of our player's health is visible at any point. So if we do 0.33 or 0.66, we can tell that our player has taken some damage. To do that, we will have to create a new script. Let's call it UI controller, and let's create a new object called UI controller. Let's attach it, and let's open it up. We're going to want to have a reference to that image we created. So we're going to do private image, and we're going to call it heart image. As you can see, there will be a problem here. That's because we need to have reference to the Unity UI engine. We can actually access the properties of this component. Let's get a reference to it. We're going to do heart image. We're going to do get component, but we're going to game object that find. We have to make sure that we give the heart a very distinctive name, so let's call it heart image, and we're going to find it by looking for that name. So we're going to create a new struct. We're going to call it UI, and we're going to keep one element for now. We're going to call it heart image, heart image, structs that UI that heart image, and then we're going to get the component of it, image. Now we will have to manipulate it somehow. Let's create a public method that the player can interact with to change the image of the heart. So let's do public void heart image update. We're going to change the fill amount, and that's going to be passed to us from the player. So it's going to be a float of new amount. Let's go out of player stats. So in this situation, we're going to edit our health and death tags. We're going to do that by first creating a max health the player can have. So let's do this by doing private integer, and we're going to do max health, and we're going to make that equal to 3 as well. We're going to go into our player, but before that we have to get a reference to this object. So we're going to do a UI controller. We're going to create a variable called UI controller, and just like before, we're going to find and attach it at the beginning of the game. UI controller, so that we can actually use it here. So in our death tag, we're going to go UI controller dot update heart, and what we're going to do is we're going to do player life over max player health, and this is going to calculate the value. We need to make sure that we set this to be a float. That way the division ends up a float, and we're going to do the same exact thing in our player health. The only thing we have to do now is, since player health is maxed out at 3, we have to check that the player never actually goes over 3. So if player health is larger or equal to 3, return. This means that if the player touches a heart but has full health, the heart will not be collected and it will be saved for later. Let's save that and test start our game. So as you saw, when the player walks through a heart and they have full health, nothing happens. If the player dies, the heart shrinks, and if the player picks up a heart, the heart returns. Next, we can work on creating a second object that we want to show off, which will be a coin image with a counter. Let's create a copy of our heart, rename it to coin image. Let's change the actual image on the surface to a coin, and let's move our coin to the other side of the screen. Now, unlike the heart, we want the coin to be connected to this corner, so it's always near it. But unlike the heart, we will keep the image simple. The way we're going to display how many coins the player has collected is with another UI element called text. Let's rename the text to be coin text so we know what it's for. Let's place it here. Now currently the text is white, so it's hard to see, so we can go into our vertex color and change this to black. And for now we can type in anything we want here. Let's type in 0 out of 10, and that's how many coins the player has collected. We can also change the size of the text. We can change the font and how the font is displayed. We can also change the alignment of the text. Let's make sure that it's centered on both ends. If we zoom in on here, you can see that there's a yellow square around it. This is the perimeter where the text is allowed to be displayed. If I shrink it, you'll see that text starts folding on itself. We can keep it as is for now. And let's just center it with the coin. And let's go into our code to manipulate this text so it displays the actual amount of coins the player has collected. Let's go back to our UI controller. Like with the heart, we will have to get a reference to that image text. So this time we're going to actually have to say text mesh pro GUI. GUI is important. There's a difference between GUI text and regular text. Make sure that you use the GUI. We're going to call it coin text. And we're going to go back to our structs like before. We're going to create a new variable for it. We're going to call it coin text. And we're also going to have it look for that as our text. Let's save it. Go back here. We're going to create a copy of this. We're going to have the coin text be assigned. We're going to do it by coin text, and we're going to have a text mesh pro GUI here. We're going to create a new public variable. We're going to do void coin text update new amount. This time it can be an integer since there is no need to calculate percentages. And what we're gonna do is do coin text that text equals. We're gonna create our own string here. First thing we want to do is have the new amount, but then we're gonna have a divider string, and then we want to have the number of coins that are in this level. Now we don't have that, and the player doesn't have that. The UI controller will calculate that at the beginning of the level. To do that, we will first get a variable, private int coin count. For now, we'll set it to 0. And then at the start of the game, coin count will look for an object. That object will be called coins. So let's add that to our structs. We're going to create a new one called coins. We're going to look for a game object. Find by structs UI coins. And this time we're going to get the transform. And we're going to get child count. Child count tells us how many children that object has. So for instance, in this situation, there are 4 coins in the level. Finishing off our string, we're going to have the coin count be the end of it. One last thing we have to do is connect it in our player stats. So we're going to connect it by doing coin text update, and we're going to give it the new player coin count. Let's save and test it. As you saw, the code worked. However, we do have a problem where our base text is overlapped until the player collects the first coin. We don't want to do that, so we should initialize it at the beginning of the game. Going back to our UI controller, after everything is initialized, we can call one heart update image with 1 full value. We can also call text update with a 0 value. That way the hearts show as 1 full health, and coins will always show as 0 out of whatever is the current max amount in the level. Now there is one issue with the text. It is kind of ugly. It's one of the basic Unity fonts that is provided to us. We do have 2 different ones, but we will want to have our own. To do that, we can download a font style from the internet. If you go into your fonts, you will see there's a bunch of different font types you can use. This will not be able to instantly be integrated into your game. You first have to convert it into a font asset. To do that, you can right click on text, you can click create, and then you will find Text Mesh Pro font asset. With the font asset, you will actually have a lot of control over how the text looks, and you'll be able to edit it. If you open it up further, you can actually change the way the text displays and its outlines, underlines, and everything. Let's connect it to our script. Now our text is a bit more blocky. Let's make it a bit larger so it's a bit easier to see. Next, we will create a new UI element that will show us a menu that will allow us to control the audio and exit to the main menu if we wish to do so. To do that, let's start by creating a UI element called panel. We'll leave it named panel. As you see, the panel covers up everything. We haven't spoken of image order as we have with regular sprites. When it comes to UI elements, the hierarchy is the order which elements display in. So right now the panel is on the bottom, so it's the most close to the camera. If I move the panel back, you will see that the other UI elements are more visible. Inside this panel, we will create more objects. Let's start with one of the simplest ones, a button that will let us go back to the game. Let's right click on the panel. Let's create a button. The button will always come with a child that is a Text Mesh Pro and some kind of sprite that will cover it up. Let's make the button a bit larger. Let's make it 3. And then let's move it. We will rename this button to say back. And then we can also create a second button. We can use the inspector to make sure that they're equal distance from each other from the center line. This is going to be the menu button. And this will have menu on it. Like before, you can actually attach the different fonts to these guys, so the font is consistent throughout the game. And we can go to our sprites folder, UI, and we can cut out a button type that we'd like to use for these. I'm going to use a green one. We will have to first change the sprite mode to multiple, and we're going to make sure that the filter mode is point, and we're going to apply it. Open up the sprite editor, slot it in here like before, and instead of using the slice method, we can actually just hover and rubber band the selection of the object we want. Apply. As you can see, only the one I selected will be cut out. I can go back to my scene, look at the button, and then change the UI element to look like it. As you saw, you can click the buttons around, but they don't do anything right now, and currently they obstruct our view. So let's go to our script and mitigate that. We will create a private component. It's going to be a game object, and it's going to be the menu panel. We're going to go back to our structs. We're going to create one more variable called panel. Panel. Save it. Go back here. We're going to get the game object. Menu panel. It's going to look for a panel. And we don't need to get any component because we're getting the game object itself. Now at the beginning of the game, we want to make sure that the panel is turned off. So we're going to set it to be active false. And that's how we're going to turn it on and off. We're going to bring back our update method. And the update method is going to check if the player has touched the escape key. We're going to go input, get key, escape. And if the menu panel active is true, we'll make it false. And if the menu otherwise, we're going to make it true. So if the player clicks escape and there is no menu panel, the menu panel will pop up. If there is a menu panel and the player clicks escape, the menu panel should go away. We will also create 2 methods, one for back button, and this is going to turn off the menu panel. Let's test if our escape key works. What we're going to do is we're going to click on the button, and then at the very bottom here is the button controls. This controls how the button behaves, how it looks normally, how it looks highlighted if someone's pressing it, and so on. The on-click section determines what the button will do when clicked on. We're going to add an action. You have to drag a script that is in the scene for this to work. So you will do UI controller, and we will choose a function, which is back button. So now our back button works. Now we need to implement our menu button. We're going to create a second method that's going to take us to the main menu. Now what this one's going to do is we can look in our player stats, we can look for scene. We're going to take the scene. We're going to change scenes, and this is going to be the menu scene. Like before, we should create a separate struct for our scene names. Scenes, menu, menu, save. Structs, scenes, that, menu, save. Let's go back to our Unity. To do that, first we need to create a menu scene. We already have that. You have to make sure that it matches what it says in our struct. So now, as you can see, I changed the menu scene here. Before, I was going to call it just menu. Now it's called menu level. If I had menu scattered throughout my different scripts, it would have been a problem. Like the back button, we're going to go to onClick. We're going to drag our controller, and we're going to put the controller to use the menu button. As you can see, it worked. Our menu button took us to the menu. However, there's nothing there at the moment, so it doesn't really matter. One last thing we're going to implement is sliders. They are also going to be under the panel. Let's go to UI, and we're going to implement a slider. These sliders will control the value of our sound effects and music audio. Let's make the slider much longer. It's good. We can call this one sound effects slider. And let's create a second one. We're going to call this one music slider. Let's separate them. Let's move them both a little to the right. And let's create a text for them that will define to the player what these sliders do. So we're going to create a text. We're going to make sure that the text is black. For this, we'll create a new font, so it looks slightly different for us. We're going to create a TextMesh Pro font. We're going to call this slider text. We're going to attach it to this text file. We're going to make this large, and to just show how the different text can interact, we're going to give this one an underlay, which is a separation of the text. It's like a shadow. We're going to change the color of it. We're going to give it a little glow. We're going to change the color of that to, and that should work. As you can see, you can create two different looking texts with one font asset. Now let's actually name this sound effect text. Let's call this sound effect volume. And we're going to create a copy of it. We're going to place it here. And we're going to do music volume. Now, the sliders come with an extra section on the bottom here. You can control which way the slider moves and how it's positioned. We're going to start with both sliders having a value of 1, so they're fully turned on, and the player will be able to adjust the volume. We're going to create two more variables in the UI. We're going to call them SFX slider and music slider. Let's connect them in our UI controller. Slider. And we're going to do the same thing here. Let's save that. Now let's create a connection to the audio source, since we'll be working with audio at this point. Let's do private audio source controller. Let's connect to it. Game object, find by type. Now that we have it, we can create a new method. We're going to do public void update SFX slider. And then here we're going to copy the value we have from the slider and pass it over to the audio source that's going to adjust the mixer. So to do that, let's hop into our audio source. We're going to have to create a new variable. It's going to be called public mixer. Connect it externally through the inspector. here called public void update SFX group. Here we're going to take in float, new volume, and we're going to update our mixer. To do that, we're going to do mixer set float. We're going to have to give it a name that we want to refer to, and then we're going to pass in the value. This works very similar to the way the animation system updates its states. Now, what is the name that we call inside the mixer? To do that, we have to go back to our Unity. Looking at our audio mixers, let's look at our SFX group. You're first going to have to go to your volume over here, right click on it, and you're going to expose it. Exposing it allows you to interact with the variable and adjust it. After you've exposed it, it's going to show up here in the audio mixer settings under expose parameters. Right here is going to say my expose parameter. Let's rename that to something easier to remember. SFX volume, and now we'll be able to access it through that. Instead of hard coding it, let's go back to our structs and add a new struct for that. Mixers SFX volume. Structs mixers SFX volume. Alright, let's save that. Let's finish off our slider controls by actually calling that method here. So we're going to do audio source controller, update SFX group, and what we're going to do is we're going to get our slider. So we're going to get the SFX slider, and then we're going to get the volume from it. Let's save that, and let's connect it in our Unity. Looking at the SFX slider, to on value change. So instead of being on click, it's whenever the value changes on the slider. We're going to click add. We're going to connect our UI controller to it, and we're going to select update SFX slider. We have to remember to connect the audio mixer. So we're going to test out our slider now. We can look at our audio mixer SFX slider over here to see how our slider is affecting it. As you saw, it only hovers between 0 and 1. That's because that's what our slider has the min and max value of. However, as you can see, our audio is between -80 and 20 decibels. To translate our 0 to 1 value to this -80 to 20 value, we're going to use a logarithmic function. So let's go back to our audio controller. We're going to replace this with math f that log10. This will change the scale from 0 to 1 to a logarithmic version of it, and we're going to multiply it by 20 because that's the increments that it changes in. Let's save that and test it. With our new logarithmic method, the volume actually hangs between 0 and -40. However, you may have noticed a bug. If the slider goes all the way down to 0, the audio jumps back to 0 decibels. That happens because the log of 0 is 0, so we want to make sure that this is not actually 0 but a very small number close to 0. With that in mind, we can do the same thing for our music. So let's go into our audio mixer for music. On the volume, let's expose it. Let's rename it to music volume. We can go back to our script. We can create another method called update music group. We're going to make sure to do the music volume, and we're going to have to go to our structs, create a music volume here as well. And lastly, we'll create a update slider method that will connect to our slider. So we're going to do update music. We're going to do update music. Save it and test it. Let's go to our music slider, attach the UI controller here as well. Let's do update music slider, save it, and let's test it. And with that, we have perfectly functioning UI connected to our music sound effects. Do one more thing, we would like to connect our canvas underneath our UI controller, and we would like to make our UI controller a prefab so we can move it between different scenes and save any changes we make along the way. This will conclude this part of the video. In the next part of the series, we'll create a menu scene that the player can start the game with.